Hello everyone. Hello Professor. I'm Pritma Samineni representing Group 18. Today we are going to explain about the risk assessment of additional works in railway construction investments using the Bayes network. Here are our team members, myself Pritma Samineni, Murali Krishna and Gautam Kumar. So coming to my part, I'm going to explain about the abstract part, introduction, which is a risk management and the risk management process, and also the framework model for the risk assessment method. So coming to the first abstract part, so what actually the artificial intelligence involved in this risk management is, like we all know, artificial intelligence is becoming increasingly prevalent in various engineering fields, including railway transportation. However, because of the different, variety kind of new terms and meanings associated with them, there is a risk that railway practitioners like others will become lost in the ambiguous and fuzzy boundaries, failing to recognize the true opportunities and potential of machine learning, artificial vision, and big data analytics, to name a few of the most promising AI approaches. An approach for developing risk management plans based on a standard formula is offered, which comprises risk identification, risk analysis, and the risk evaluation. So what here it is all about the railway construction investment using the Bayes network. So what actually the Bayes networks is, it is a type of probabilistic graphical model that is widely used. A Bayesian network is a representation of a joint probability distribution that is flexible, interpretable, and compact. The Bayesian network in artificial intelligence can be used to create models from data and expert opinions, and it has two sections, a table of conditional probabilities and a directed graph. For example, like it could be used to address the probabilistic links between symptoms and diseases. The network can be used to register the likelihood of certain illness arising based on symptoms. So here we have two like parameters, like one is the structure and one is the parameter, and the structure is a directed accurate graph that conveys conditional dependencies and independence between an element of a node. And the second one is the parameters, which includes a limited cycle of possibility for each and every node. So this is all about the abstract part. Coming to the introduction, which is a risk management. So the construction risk management is a process of identifying and applying methods to reduce the impact of danger on a construction project. The process of this risk management entails significant planning in order to build risk management techniques that will assist project managers in identifying, monitoring, and mitigating risk. So here we have two most important concepts. One is the Project Management Institute, an Institute of Civil Engineering. According to ISO standard, risk is calculated with the formula like R is equal to F of P comma C, where R is considered as a risk and P is the possibility of certain event occurring, and C is the impact or consequence of events consequence and the related probability of its occurrence. So to determine the possibility of a specific event, the quantitative and the qualitative research is undertaken. The consequences of emerging risk are given as a change in the investment duration or as an addition to the standard. Various risk qualification methodologies are changed in the project cost. On the other side, a well-designed risk management strategies contributes to higher revenues in a variety of ways. So this is all about the introduction of the risk management. Well, coming to the process of it, here we can see in the diagram, like we are having a risk assessment in which we have risk identification, risk analysis, risk evaluation, and the risk treatment. So what actually these risk assessment parts are, coming to the first one, risk identification, which is a technique for identifying obstacles that may prevent from you achieving our objectives. Uh, Risk analysis entails identifying the causes and the cause of known risk in order to identify remaining risk, as well as assessing the probability and outcome of an event in light of existing controls. Well, coming to the next one, the risk evaluation, it compares the result of risk analysis of a risk criteria in order to determine whether the risk is worth or not. The last one is a risk treatment, changing the amount and probability of both positive and negative impacts in order to generate a net profit increase. So this is the process which is represented in the diagrammatical form. So coming to the next slide, which is a framework model for the risk assessment method. So here, the risk assessment is divided into three stages according to the standards recommendations. The first one is the risk identification, and the risk analysis, and the risk evaluation. So the risk identification is a structured or semi-structured interviews, and the risk analysis is a Bayesian statics and Bayesian networks, and the risk evaluation is a probability matrix. Like each stage denotes a particular method that is a part of the risk assessment. The sections of the standard outline the essential assumptions and activities the decision markers managing risk in the company should take for each of them. From the above diagram, the risk assessment stages and strategies utilized for extra work on railroad development, investment, or represented. So the data here will be encouraged to be evaluated using one of the network known as a Bayes networks, which allows for modeling with a high degree of vulnerability or based on cause and effect nothing. The result or probability network will be used to survey risk, allowing us to clearly build up the amount of risk and carry out exercises aimed at reducing it. According to developers, they suggested this. So this is the framework of the risk assessment method. From the next slide, our teammate going to continue. Thank you.
Thank you, Pratham. So, hello all, my name is Murali Krishna Bomisity. So, I'll be discussing these topics in this paper. So, the first one is identification of risk of additional works in railway projects. So, in accordance with the adopted assumptions, the authors prepared a questionnaire with questions that allow for the identification of the most important parameters, describing emerging additional works in rail infrastructure construction methods in Poland. The respondents are asked the following questions. So here, these are the following questions which are asked in Poland, and here the choice of experts was deliberate and the research was conducted in form of interviews. Each respondent represented different company and was chosen consciously by the authors. Respondents were asked to describe the risk factors and types of additional construction works that might lead to increase the cost associated with the major project. The respondents were also asked to assign a probability of occurrence expressed in percentage to each given answer to each answer given. Determination of level of probability of the consequence of the additional work was included in Bayes network model represented in next section. Here in table 1, it explains the risk identification for additional works and results. So the results of analysis were presented to an expert with the highest level of seniority and expressing in the area of rail engineering. Risk identification in accordance with the standard guidelines should include the following elements. The elements are determination of risk, determination of consequences, determination of possible scenarios. The answers given by the respondents were grouped according to proposed scheme. As a result, three groups were obtained, which are presented in figure 3. So here figure 3 explains the three groups which were obtained in this. So now we are going to discuss about risk analysis, Bayesian statistics, and the Bayes network method. The selection of factors used to build the proposed risk assessment model is presented in figure 4. So this is the figure 4 which is talking about, and here these are the factors used to create model for risk assessment. The factors include bad organization of works and changes in design and sustainable errors and incompletes, and the remaining are these which are explained. The Bayes network method was chosen, which seems to be most appropriate for risk modeling. Based on the results of the research, the others choose the factors where the probability of occurrence was most highly rated by the participants. The Bayes networks were chosen as it allows the introduction of new information to the model using expert knowledge or historical data. Risk analysis was carried out in 4 stages that were related to Bayesian network design. The software Natia software was used to build the model in the form of Bayes network. These are the individual steps. The first one is creating the node of Bayes network, giving relationships ships to particular nodes, assigning event probabilities, and performing calculations. And next here we are going to look into creation of nodes of Bayes network. The assessment model has 9 nodes, each of which the assigned unique correspondings to the characteristics of given node. Selected risk factors, the probability of additional works, types of additional works, and consequences of this phenomenon were used to create the nodes of Bayes network. In the model's operation, the events at the later stage are described as part of consequences of their occurrence. The Bayes model has not has not been studied before using the Bayes network. So the authors do not have any primary network that can be modified. The uniqueness of the studied problem required the creation of indirect event in the form of Bayes network space. This event was modeled by connecting the nodes constituting the risk factors and the effects of the appearance of different types of industry works. The network proposed in Figure 6 was used for further calculations. So this Figure 6 is used for further calculations, and you can see these are the items which are included here. For each of the 9 selected risk assessment factors, uh, an analyzed process of attributing possible events were carried out. The event was modeled by connecting the nodes constituting the risk factor. The relationship will be used to examine the possible scenarios or consequences of events occurring in the process of assessing the risk additional. So here are the 9 factors which are discussed here. Next, we are going to discuss assigning the event probabilities. Bayes network is Bayes model is based on the fact that there are many possible combinations of consecutive events and their probabilities. The correct functioning of model requires assigning to each event the probability of its occurrence. The other nodes are connected by mutual relations must be described using so-called conditional probabilities, which are based on chain method. Chain method AL properties probability tables. An example of conditional probabilities is presented in Figure 7. So here the Figure 7 discuss about the conditional probabilities for additional work. Determining the probability of all events is labor-intensive process. It is important to identify events and shape the implementation between them. Next, we are going to discuss about performing calculations. Creating an extensive network requires appropriate programming, which can be associated with great difficulties. The basic relationship used in construction of Bayes network is the theorem of Thomas Bayes, binding the conditional probabilities of two events conditioning each other. Applying this to the series of events allows us to determine the probabilities of all events forming the network. The network after calculations together with the determined condition probabilities is present in the figure. So here we have a Bayes network after the conditional probability of calculations. So from here, my teammate will continue.
Thank you, Murli. This is Gautam Kumar. Today, I'm going to explain about risk evaluation by building a risk assessment matrix. Here, we are following 2 scenarios. One is event scenario analysis. Another one is risk mitigation proposal. Next slide, please. So first, we are going to discuss about a risk assessment matrix. This matrix method was proposed to determine the risk criteria in this paper. The method corresponds to the assumption of the work in which the risk is expressed as the product of probability and its effects. To do this analysis, we need to have specified ranges of probability values and effects of events and adapting point values for these ranges. There are different types of risk assessments which are categorized based on the point values, which will be seen in the next slide. Next slide, please. Yeah, here we can see different risk level ranges. So comparison of this risk criteria requires a reference to assumed risk levels. 4 levels of risk were determined, that is low, medium, high, and very high. So based on the point range, we are going to divide these ranges. So the proposed scenario includes a proposal for further risk management. Matching the risk to the appropriate level requires specifying a point range from values 2 is the lowest and 50 is the highest value. These ranges of risk levels together with point values and scenarios of actions are displayed in the above table. So in addition to these ranges of values, there are other indications, that is color. So they are using some particular color coding for representing these risks. So for low risk, they are representing the blue, and for medium risk, they are going with green color, and for high risk, they are showing with yellow, and for very high level, they are representing the data with a red color. So individual variations are made by indicating restrictive probabilities of these chosen hubs. It is feasible to digit various degrees of occurrence details. In this work, one selected scenario of events will be analyzed and risk will be evaluated in accordance with the previously estimated procedure. Next slide, please. So here we will dig into the two steps which we are going to discuss in the further slides. First one is event scenario analysis. Here we will analyze the occurrence of the risk factor, including occurrence of project document errors, which we shown in the above image. The effect of occurrence of an event involving the existing of faulty design documentation. So the extending of the duration of implementation to around 3 months will be like 36.0%, which we displayed in the last table. So if the duration is around 3 months to 6 months, means the time taken will be around 40.7, and if the duration is around 6 months, means it will be around 23.3%. Individual variants are created by specifying restricted probability for the selected hubs. It is feasible to digit various degrees of occasional details, yet to circumstance the best mirrors that situation are convincible in the accuracy. The acquired results enable the categorization of probable occurrence into two risk groups. Low risk, that is range from 2 to 5, and a high risk will be around 19 to 20 for this particular analysis. So when when there is a significant amount of risk, a cautious way of risk reduction has been offered, known as risk mitigation, which will be seen in the next slide. Next slide, please. Yeah, here the risk mitigation proposal includes the scenario of the occurrence of errors in the project documentation results in appearance of high risk. The best risk management strategy depends on variety of factors and includes a response to each type of the risk in this project. So in order to gain these things, we need to follow a few steps, that is risk avoidance, risk transfer, risk mitigation, risk acceptance, and emergency plan. Among the possible strategies to choose from, the above mentioned steps will be considered for gaining for implementable in this process for railway investment implementation. Risk mitigation is the strategy of reducing the likelihood of effects on the adverse risk event to an acceptable level. Examples of these procedures include checking the documentation created by an additional design office, analyzing of industry experts, or use the typical catalog solutions. These network model together with the reducer risk factor for the faulty design documentation will clearly explain the risky level in any particular project. Next slide, please. So in conclusion, we can say that in this paper, a standard algorithm that includes risk identification, risk analysis, and risk assessment is proposed. This method allows for the construction of complex impact networks that can be modeled on the basis of surveys, historical data, and expert opinions. Using the network, the user is able to compare different ways to reduce risk, check the effect of reducing the risk factors, causing additional works on the other types of networks. The proposed model is simplified version of the Bayes network created by the authors, which will be used to study more factors and effect of the risk in additional works. So the author in this paper also plan to implement new network learning using new information obtained from expert opinions or historical data. Yep. Thank you, Professor. Thanks for the time.
Thank you.
Thank you.